it's kind of like, I'm thinking with footballers here, it's kind of like when they win the World Cup. That's what it feels like to me sometimes when you solve that massive problem. It really is that amazing moment. Well, for me, computer science, it's about automation, fixing things, problem solving. That's what it really comes down to for me. And if you enjoy problem solving, there isn't a better way of being able to put that into use. I mean, automation, you can code, you can learn to code. There's just so many different things about computer science that make it so vast and fun. I know all of us here could pick out many different areas. Depends on your passion. For me, I'm passionate about computers. I'm passionate about problem solving. So study computer science if you enjoy that. It is the most rewarding subject I've ever found in my life. You go around the office sometimes like, high five, solve something, because the complexities that you can come across, they can be huge. You can spend 6 months building something, and then you have this eureka moment, and it's euphoria. It's kind of like, I'm thinking with footballers here, it's kind of like when they win the World Cup. That's what it feels like to me sometimes when you solve that massive problem. It really is that amazing moment. So studying computer science, it gives you the skill set to go off and learn the skills to teach yourself and to then apply that and problem solve. That's what it is to me.
I think a lot of that is the versatility as well. It's not just going and learning programming and sitting in a basement. I think for some people it is, and they like that, and that's okay. But if you don't want to do that, there's other stuff you can do.
Oh, there's massive.
Yeah, I'm trying to. Yeah, it's easy to
managers,
say. Yeah,
data science. There's research analysts. There's so many different jobs that you can do. Teaching. It's another outcome, isn't it? Mm-hmm. And there's loads more that we're not even touching at the moment. Programming is just one of the core fundamental kind of things that people think when they see computer science. Yeah. It's like, you're all programmers, you're all nerds. No, actually, well, we are probably, some of us anyway. I am for sure. Yeah, I've got friends that are now kind of managing companies, leading companies with 100 to 300 people. And they've come from computer science, went off to do different like masters after that. So they've actually changed career path and gone into forensic science and applied it in different ways. So it's a massive open door to the whole industry.
It gives you the skill set, like you said, with problem solving. You can apply that to any aspect of life, I think.
And it builds up your resilience because, as you said, it can literally take months and months of the same thing, reading through your code over and over again, thinking, oh, I might have solved it this time. And then actually you've made it 10 times worse, and you've got to go back and look at it from a new perspective every time, get help with it, and then eventually there will be something that works, but you will never forget that thing that made it work.
Yeah. That's how rewarding it is, isn't it? That you look back this is one thing that I can say to my team quite often is like, if you look back after 6 months, you can see all the minor and major improvements you had, and you were so much a better person programmer. You've learned how to problem solve something, and you grow always. Yeah. And if you haven't, then you probably need to question, like, why am I not growing? Why haven't I grown? Because I can see throughout my career, every 6 months, everything I've done is much better. And I look back and I go, wow, I wrote that. That is horrific. And that was only 12 months ago.
I think there's definitely industries where people settle into one thing. It's like we've all heard the story of like the guy at Ubisoft or whatever, who's like the cape guy. He just makes capes, that's all he does, and he's sick of it. But then when you work in a smaller company, it's to the point where you're solving a problem you have never touched before, you have no idea about. But it's like, this is your problem, so you have to research. And I think a lot of people who get into even just like games designs, they're looking on YouTube, they're doing online courses, they're teaching themselves, but they're teaching themselves the fun stuff and sometimes not always the problem solving, not always the fundamental stuff that you are forced to learn at university, whether you like it or not. Yeah. And once you actually get into an industry, you're like, wow, if I hadn't had learned that, I wouldn't be where I am now.
Yeah. I think the fact that problems in so many different areas as well. That's where the interest can come in as well. You might have an interest in a different domain or a different subject, but you know, you need to use some computer digital service to actually solve that problem. And the fact that the infrastructure and the, you know, the way we interact with software and services is in so many places, so many different touch points in our physical world, in our online world, on the world on our mobile devices, our wearable computers. They all bring with them the chance to solve new problems because it's a different context that they're being used in. And if you have an interest, whether it's in, you know, sports tracking, you know, you might be looking at how you're going to use software to do that. If it's an interest in how you manage, you know, getting around a building and the infrastructure in a building, how you control, you know, the building itself, you know, those problems are all there to be solved, and they need, you know, a range of skills to come into it, but they also need the computer science skills to actually make it happen.
Yeah, and it's so much easier nowadays because we've all built these toolkits.
Yeah.
I mean, the industry is in a much better place than it was 10, 15, even 5 years ago. And cloud's made a massive difference, hasn't it? You know, like where you can push events and magic happens. I mean, a light switches on in another room that's not even in the same house.
As well as that, there's so many communities now. You've got like whole of Stack Overflow. There's lots of groups on and pages on Twitter. Or you mentioned YouTube communities. There's just so many places now where you can seek other people and find new ways to do things or find help for things. So it's one of those subjects where you're never alone because everyone's in a similar mindset.
It's not like back in the day, you know, where there was that one, I remember my mum telling me, it's like there's not that one kid in your school that figured out how to program something through trial and error. And there wasn't any teaching otherwise, but that one kid figured out how to do some on the ZX Spectrum and everyone else in the school had to figure it out as well. Just because there wasn't the kind of, you couldn't Google it, obviously. But now it's kind of, it's so much more information out there, and I think it just makes you look at things differently, and it's just good getting those other perspectives on it as well. I mean, I've had friends read my code and they just looked at it and gone, what have you done there? Why have you done that? And I'm like, I don't even know, please help.
I think I've been one of those at some point
You've
before.
100% been one of those.
What's interesting though, when you both said that, is that, I mean, sometimes a light switch needs to just do the job of turn on, off. You mean, yes, you can have spaghetti code underneath and it could be not the most aesthetic, but does it matter if it actually does the job? It is actually fit for purpose. It's done its requirement. Yes, you could probably refactor it 1,000,000 times over and have 3 lines of code at the end, but it doesn't matter. Sometimes it's about just the end result, isn't it?
Mm-hmm.
I think you get to a point where you're like, oh, it doesn't matter. Like it's a bit slow, the latency, and then somebody goes on the switch and it breaks, and you're like,
Yeah.
oh, I need to fix that actually.
Light bulb popped.
It's that balance between having, you know, the value that your feature's delivering, but also the engineering of that feature. You know, both are important. You know, you need to engineer that it is all of those kind of quality things, that it will work under pressure, but equally, what's the switch doing and who wants to switch it on?
That's why we need people who break stuff.
I'll always be there, don't worry.
I think for me, one of the key reasons to study computer science, one of the reasons I've enjoyed teaching it for a few decades now, is that it gives our students, later on graduates, the skills to be able to use computers to solve the world problems. There's so many areas we can cover with it. Again, at university, in a computer science degree, we can give students the chance to meet lots of different parts of computer science and learn how you can apply it. So we learn about software engineering. So if you're going to build a system that controls the brake system in your car or life support system, you can't have spaghetti code. You've got to know this thing will work. If it fails, I know why it will fail. And we teach students with software engineering approaches for that. I think I was teaching them about the fundamentals of it. One of the things I do in the first year module that Ethan Allen might remember is about things like the limitations of computer science as a logical system. So we can show why we'll always need some human programmers. One of the questions is, like sort of in Terminator, if programmers get that good, they'll program themselves. But actually, there's things we can't answer with logic purely, and you need something beyond that. And it's a fundamental science we can teach, so you understand what computers can do and what they can't do, and the limitations.
And that's why I like this course so much, because we are shown so much and so many areas of the course that it can branch into in that first year. And then we can basically follow a path if we desire and specialise within it later on down the line.
Yeah, it's nice when you're seeing sort of graduates come back as well. So people who've set up companies, different areas, virtual reality, computer graphics, applying e-commerce, a whole range of things. They come back to, or students email you a few years later, want to get in touch about something, and they're running multi-million-pound projects at a major pharmaceutical company. They say, okay, where they've gone career-wise isn't computer science itself, but they're taking the problem solving, understanding what's possible, managing people. So things that, again, people that always see in computer science, they think it's purely technical. It is technical, but it's also other aspects of problem solving and things that make computer scientists really, really employable and important
I
as
think
well.
we're at a point where in the industry where everybody or everything is trying to move online, and it's to a point where everybody needs to be at some level of like tech literate and competent. It's like even our marketing guys, he studied English. He's now in charge of like writing some of our webpage for us to make sure the content's up to date, and he has to learn how to be able to put the text in and the images and line them up and make it look good as well. And there's a bit of programming that goes into that he's never touched before. But I think in the same way that people come into computer science, when you study it, you can absolutely branch out and do, was it forensic science?
Yeah.
As well, criminology, things like that. Those skills are always going to be useful, even if you decide it's not what you want to do anymore.
As you say there, it may look difficult to begin with, the big scary computer science, this big thing, but it's actually not that bad once you get started. You can start quite simply and then start building more and more skills up. As you said, you look back in 6 months ago, you go, what on earth was that? What have I done there? It's a continual evolution of yourself, basically. It's one of the reasons why I like it is it's never the same. It's always getting better. It's always changing. It's always evolving.
One of the bits that you mentioned there, which I really like, is I'd never programmed before I came to university. I'd wrote some, like, I don't know, run, start, that type of thing, some maybe batch files, but I didn't know there were batch files at the time. But my computer literacy, I could build a computer, I could fix it. I was a good tech support. I could not program. But after being through 3 years of university, I could program. It was great. We used to do stuff with like assembly language as well. So we went really low, middle, and high. So that base for Hull University for me was massive. I definitely wouldn't be here without have had all of those different aspects, and I wouldn't be the programmer I am today. And I definitely wouldn't have seen going back to an earlier version of me at 12, 13, even 16, 18 before going to university that I'd be a programmer. 100% definitely not. But I can now, and I love it. It's so rewarding.
I think going to university and sampling a little bit of everything at every layer really helps you decide where you want to be and where you would like to almost just like settle and find a comfort zone. Where even when you are just programming on this one layer, there's still sometimes you have to dip down and do some other stuff or make something really simple for somebody else. That's if that was the first time you were seeing it, it'd be scary, but because the first time you saw it was in university like 3 years ago, you're like, oh, yeah, I know this. I'll pick that up in a week. That'll be all right.
I do have a comment though. It's like, does everyone that you speak to that you kind of go, I'm doing a computer science degree, they're like, super admin, super nerd, excellent. And it's kind of like tech support. We all get that. And it's kind of like, but it's because of those basics that we've learned. It really is that you do know how to run Windows, Apple, fix things. It's just that problem solving, isn't it? It's across the board. We can all do it.
It starts to become intuitive as well. It's like you see something new and you're like, I've seen something similar to this. I think it works like this. And then you do, it works. Oh, excellent.
And that's like when you start to learn a new language, you go, oh, well, you do it this way here. Because like all the fundamentals remain the same. It's just the way you write it changes sometimes very slightly, like between Java and C#, sometimes vastly differently with Python. But it's all quite interesting and quite quick to pick up as well.
Yeah.
It's getting that toolkit as well, isn't it, really? You know, to look at what tools you need to solve that problem, and whether that's a particular language or a particular approach of running a project for a particular way you're needing to do that. So there's the kind of discipline toolkit, but then there's also the other stuff that goes around it about understanding why you're doing something and what the impact of that is, you know. And I think it's having that broad thing about the discipline stuff, but also you as a learner and how you learn through your time here. And also going back to the, why study computer science and thinking about jobs, it's kind of thinking about jobs from early on as well, and actually trying to research, what are the different roles in this domain, in this subject that is computer science. And there are so many. And I think trying to understand those from an early point in a degree is really useful, because you can then start to think about where do you want to focus, what do you want to do for your kind of big third-year project, where you want to really spend the time working on an area. So I think, not just getting to third year or fourth year, whatever year you're graduating, and then going, what do I do now? I think it's important to be exploring that kind of along your journey, really.
In computer science, some problems we solve, we're saying, well, here's some software for doing it now, but next year that software might be obsolete. But the approach, that's now universal. That pattern, that approach is something we can use again and again. And 10 years from now, people can apply it.
That's one of the greatest powers about computer science, isn't it? Is that at the moment we're building everything for the future. Every little bit that we add to it, like in communities, what you guys are doing right now, you might just change something, add a little bit extra code to a GitHub repository that becomes something massive. We're all setting up the future right now. And
you're still making something that hasn't ever been done before.
Yeah,
that freaks
not
me
like
out.
Neil, who's kind of changing the world in 9D.
That's interesting though, because you forget that there's science. It's not just computers. It's not nerds sat in their basement like writing the next whatever. There's a science to it, and there's a method, and you need to know that scientific theory to get anywhere new.
On the wall of my office, I have a couple of sort of posters I've made up from. But one of them's about kind of it's like academic genealogy. So it's kind of my PhD supervisor was kind of my PhD sort of father, and his grandfather was a lecturer at Cambridge, and you can go back and you sort of see I can trace back my PhD sort of lineage back through various famous people like sort of Fourier, Laplace, Klein. So like Klein bottles and things you come across, and it kind of goes back to I think 1640. And I have on that post, I got a quote from Newton, sort of, if I've seen further, it's by standing on the shoulders of giants. I think that's the idea that we're building, each of us might be doing a tiny little incremental step, but we're doing them. And that's how now, as humans, we can now build these systems, these complex systems. You can build a VR system quickly, you can build e-commerce.
Because all the building blocks, it's like Lego, isn't it? If we take it back to its simplest form, it's like Lego. We're all building these little blocks and connecting them all up to create, hopefully, I don't know, like a castle.